So this is page 7. Let me explain what it is we're doing today. We're going to continue to work with the vertex form of a quadratic function, but we're going to be getting more into the algebra of what's involved. Yesterday it was a matter of looking at a graph using either a graphing calculator or the graphing technology that I have up here, and talking about transformations and making observations so that you can be successful on that quiz. I know that we've just gone through this, but let me go through it again because it'll make me editing this video a lot simpler. Okay. We have learned that when you have a quadratic function of the form f of x equals a times x minus p quantity squared plus q, the vertex is identified by the numbers p and q, and the equation of the axis of symmetry is that x equals p. If a is greater than 0, then the parabola will open upwards, whereas if a is negative or a is less than 0, the parabola opens downwards. If the parabola opens upwards, there's a lowest point called a minimum, and that minimum value of y will be q. If the parabola opens downwards, then it's like a hill, and there will be a top to the hill. There will be a maximum value of y of q as well. So the maximum or minimum value of a quadratic function, if it's in vertex form, is always q, and it always happens when x is p. I'm not so sure that this is something you absolutely need to know to be successful in any way in this unit. It's just that this is how we think of things next year in 30-1. We talk about translations or shifts left or right. Q is the parameter which determines the vertical shift, and if q is greater than 0, the vertical shift is up, and if q is less than 0, the vertical shift is down. P is the parameter that tells you about the horizontal shift, and if p is positive, it shifts to the right. If p is negative, it shifts to the left. I just want you to make a mental note here. I think it's worthy of mentioning that up is positive and right is positive in terms of directions. Like if you look at the y-axis, positive means you're going up. That's why when q is positive, it shifts up. Whereas when q is negative, it shifts down because down is a negative vertical direction. And the same can be said for p being positive to the right and negative to the left. In all cases, the amount of the shift is given by the size of the parameter, irrespective of negatives, which is what the absolute value sign is telling you here. Don't worry about the negative when you talk about the amount of the shift. So you don't need the absolute value signs if those parameters are already positive, but you can certainly put them in. Now let's get to today's work. This set of examples that we're going to go through today is just as much about quadratic functions in vertex form as it is about algebra. So everything we do here can be applied, almost everything, can be applied to cubic functions or trigonometric functions or logarithmic functions or rational functions. We're not learning something that's unique to quadratic functions. So the first question says, find the intercepts of the following quadratic functions. Well, that means we need to find the x-intercepts. And if you stop and think about the shape of a parabola, it's possible there are two x-intercepts, so I use plural. And we need to find the y-intercept. And I don't want to get into a whole lesson on functions, but functions can only have one y-intercept. If you had a graph that crossed the y-axis someplace and then it crosses it again later, the graph goes back on itself somehow. It goes left and then right. And you learn in grade 10 that functions only have one y value for every x value. You may recall the vertical line test. So that says, briefly, I don't want to get sucked into a vortex with this, that says that something like this is a function, because no matter where I put a vertical line on this, it will always intersect in only one place. Therefore, every single x has only one y. However, if I gave you this, this is not a function. And by the way, you can never graph things that are not functions on your calculator. They will always go up and down, but never back and forth. So if you take a look at this particular graph, it has more than one y-intercept, and that can only happen if it's not a function. These are quadratic functions we learn about. You will just barely touch on non-functions, maybe in a couple of places in Math 30 and maybe in calculus if you take calculus. So that's why, contrary to what I wrote, that is why I pluralize the intercepts for x, but I just have a singular for y. I wrote y-intercepts, but I meant to write y-intercept. The thing that you need to remember is that for an x-intercept, y is 0, and for a y-intercept, x is 0. This is true of any graph. Because if I graph something, and I talk about these 4 x-intercepts, they all have something in common. They have a y-coordinate of 0. And if I talk about this one y-intercept, what's unique about it is x equals 0. So x-intercepts and y equals 0 go together like peanut butter and jelly. They're automatically together. So how are we going to solve this problem or answer this question? Very simply, to find the x-intercepts, we're going to take this function and write 0 equals negative 1/2 x plus 5 quantity squared plus 2. We're making y equal to 0, and then we have to solve this for x. When we rearrange this equation for x, you have to rearrange equations from the outside working in. And it's actually the opposite of bed mass. What happened to x is in brackets, first you added 5, then you squared it, then you multiplied by negative 1/2, then you added 2. We have to unwrap that by first subtracting 2, then getting rid of the negative 1/2, then getting rid of the squared, then finally getting rid of the 5. So the first step is to subtract 2 from both sides. And I'm just teaching us algebra here. You can call this solving an equation, but it's algebra. So I've subtracted 2 from both sides. There's lots of ways for you to think about what happens next, but I wouldn't even worry about the negative, because you can divide both sides by negative 1 or multiply both sides by negative 1. I'm going to multiply both sides of this equation by 2 to get rid of this 2 in the denominator over here. And when I do that, I get 4 equals x plus 5 quantity squared. So what would I do next? Well, I would take the square root, right? And by taking the square root, you get x plus 5. However, and it's just such a busy day all the time with all of these shortened classes and more classes to teach. I forget what and some of you were in one of my class and some of you were in another class as well. So I can't remember if I mentioned this to you. But what's wrong with this? I know that people in my Physics 20 class should be able to tell me what's wrong with this. And maybe I'll start by saying this means that 2 is equal to x plus 5. Would you agree the square root of 4 is 2? Okay. What's wrong with this, though? There is something wrong. Or maybe wrong is the wrong word. There's something missing here. That's not actually true. Georgia, do you know?
You have to square the other side of it?
Pardon me?
Never mind.
Okay. Well, let me just make this more general. If I said to you that r squared is equal to 4, and you say r is 2, you agree that's a true statement. That's true. What other number can you square to get 4? Colin?
-2.
You can square -2. These are both solutions to this equation. If you take -2 and you square it, you get +4. So what I've taught my Physics 20 students is when you take the square root, you write that symbol, and that means plus or minus. And if you don't do that, you won't get 2 x-intercepts, and a quadratic function can have 2 x-intercepts. And what does this mean? This literally means x plus 5 is equal to +2 or -2. It's 2 solutions now. It's 2 equations. So I subtract 5 from both sides here and I get -3. I subtract 5 from both sides here and I get -7. So those are the 2 x-intercepts. And, you know, let's get in the habit. You don't always have to do this. But if you're asked for x-intercepts, let's write them this way. Now, what about the y-intercept? Well, I need to go back up and look at this function. Don't forget the y-intercept is found by letting x equal 0. So I need to take this function, which is y equals -1/2 x plus 5 quantity squared plus 2. Can somebody just verify that I've remembered that correctly? Okay. And I put 0 in for x this time, which is really easy to work out because you don't need to rearrange anything. We do want to, and from here on in high school math, I should never have to tell you exact value. I should never have to tell you no decimals. You should know that this is what we're after. So I simplify this. I get y equals -1/2 times 25 plus 2. And listen, I don't care how you figure out what this is, but we want an answer as a fraction. This is -25 over 2 plus 2, which is going to give me -21 over 2. Because this 2 can be written as 4 over 2, and then I can put them together with a common denominator. Just for kicks. So let's write this over here. The y-intercept is 0, -21 over 2, which is 10.5. -10.5? Okay. So just for kicks, let's go to our graphing calculator and enter this function for y. It's -0.5 bracket x plus 5 n bracket squared plus 2. And this is not always the wisest move. We'll get practice with this. But zoom standard is kind of where you start. How many of you remember from grade 10, sometimes it's frustrating to get the graph to look the way you want it to look on the screen, okay? We'll work on that. That's part of the skills that I'll teach you. But zoom standard, which is zoom 6, I believe, is the beginning point, and that's good enough. So how would I find... Actually, I'm going to change something here. If you're doing this now, go to your window setting and change the -y from -10 to -15. When you go zoom standard, your calculator scales things from -10 to 10 horizontally and from -10 to 10 vertically. And when I looked at that, I'll do it again, the y-intercept is very close to the bottom of the screen. So I want to be able to see it. I want to look below -10, so I'm going to go to -15. While we're at it, why not? We have time. It's important that you can do this. Look at this image that I've just dragged onto the screen. Do you agree that this is all wasted space? There's no information to be gained by me there. And this is wasted space. So why don't I change the window settings from -10 to like 2? And why don't I change for x? And for y, why don't I go from -15 up to, say, 3? You get my drift here that what I'm talking about doing is this. I'm talking about zooming in on that. So I'm going to go from -10 to about 3 this way for x, and -15 up to about 3 the other way, or 1 or whatever. It doesn't matter, the exact numbers. I think I said initially for x, I said -10 to 2, I could have. And for y, -15 to 3. So manually changing the window settings is a lot better plan than going zoom in or zoom out. That's a horrible choice on your calculator. You can see that it crosses at -3 and -7 on the x-axis. Not today, but the next class I will show you how we can get the calculator to find those x-intercepts exactly. Okay? But we can see visually they are. And there is a quick way for you to find the y-intercept here. What is the x-coordinate for a y-intercept? What is the x-coordinate for any y-intercept? 0. If you go trace, if you hit the trace key, you are allowed to enter any x-coordinate you want, and it will plot that point. So when I go trace 0 and hit enter, there's the y-intercept, -10.5. Okay? All right, let's try another one. Okay, well, let's find the x-intercepts first. That will be found by putting y equal to 0, which means we're going to get 0 equals 4 times x minus 7 quantity squared minus 12. And we need to unwrap this equation and get x by itself. I'm going to add 12 to both sides. I'm going to divide both sides by 4. And now I'm ready to take the square root. When I do take the square root, I'm going to have to write plus or minus the square root of 3 is equal to x minus 7. Because whatever the square root of 3 is, if it's positive or negative, I can still square it and still get 3. I'm going to ask you a question. Who can tell me what the square root of 3 is equal to? It's a bit of a trick question. Because if you go the square root of 3 on your calculator and you say, oh, it's 1.7, just try it. See if my memory is right here. 1.7, I'll go, no, it isn't. And you go, oh, right, sorry, it's 1.73. And I'll go, no, it isn't. And then you go, okay, it's 1.73, whatever, and you read off all those decimals. That is not the square root of 3 because root 3 is an irrational number. The only answer to the question of what is the square root of 3 is to say it's the square root of 3. We don't want to evaluate it. We want to leave it as an exact value. All we have to do is add 7 to both sides now, and our two x-intercepts are 7 plus or minus root 3. So one of the x-intercepts is 7 plus root 3, comma 0. The other one is 7 minus root 3, comma 0. And if you want, on your own time, you can plot this in your graphing calculator and poke around and see that those numbers are right. If you did want to know what the decimal approximations of these x-intercepts are, you could certainly go 7 plus root 3 and 7 minus root 3. They will be at approximately 5.3 and 8.7 on the x-axis. Those are the x-intercepts approximately. What about the y-intercept? Well, the y-intercept is always easy, because all you're doing is you're letting x equal 0. When I do that, I get y equals 4 times 0 minus 7 quantity squared minus 12. It's just a matter of you calculating what that is. 0 minus 7 is negative 7. Negative 7 squared is 49. 49 times 4 is 196. 196 minus 12 is 184. But I just did that in my head. I want to make sure that it's 184. It is. Okay. So the y-intercept is at 0, 184. Which means if you were to plot this, you'd have to really adjust your window settings to see that. All right. Finding x and y intercepts is what I want to teach you in this first example. The algebra is the tool that we use to answer the question, but the starting point is the same. If it were a logarithmic function next year and I say, what is the x-intercept? Then you're going to let y equal 0. The algebra will be different, but the starting point will be the same. This type of question is crucial for Math 30-1. Not that it's a parabola, not necessarily that we're finding the equation of the parabola, but how we do it. And when the time comes, I'm going to highlight some key words for you. If you want to determine the equation of this parabola, and you know it's a parabola, then your problem is this. What are the values of the 3 defining parameters? This is why I stressed yesterday, these numbers define the graph. If you know these 3 numbers, if you know, for example, that P is 3, that Q is 1, and that A happens to be 3, then you would just put those numbers in and you'd be done. We, in fact, know 2 of those 3 parameters right now. Zach, what am I talking about here?
Starting at on the graph.
Called the vertex?
Yeah.
So what is that going to tell us?
P and Q.
P and Q. So when we read these coordinates, excellent. When we read the coordinates of the vertex, it's at 3, 1. Well, that tells us P is 3, Q is 1. And here's the part that is a Math 30 thing, and a Math 20-1 Unit 5 thing, and Unit 6 thing, and Math 30-1 Units 1 through 6, maybe even Unit 7. We are missing a parameter. This is a missing parameter problem. Okay? Next year, you might be given the following function. And asked to find B. You don't understand what this means, and I don't want you to understand what it means. I want you to understand that it doesn't matter what it means. B here is a missing parameter. And how you would find B in this made-up problem is how we're going to find A in this problem. You need to think of this as a missing parameter. And when the time comes, if I happen to be teaching you Math 30-1, the very first time we encounter this, I will not say it's a missing parameter. I will say, okay, who remembers what we should call this B? And it's a missing parameter. I won't tell you that. I'll be trying to get you to recall that. And as soon as you conjure up that phrase, the missing parameter is always found in the same way. Does anybody know, I'm just curious here, does anybody know how we can find the value of A? you have an idea, Zach? No? Thought maybe you did. See, this equation, I'll help us out here, is now y is equal to a times x minus 3 quantity squared plus 1, isn't it? Do you see the parallel here, everybody, between this that I've just written and this? It's an equation that has x and y and a missing parameter. So how do you think we can find the value of a using this equation?
Alina Yakimova, back to class, please. Alina Yakimova, back to class. Thank you.
Colin, do you know?
Rise over run.
Rise over run won't work because this is not a straight line. So I like where you're going with this, but this a should not be associated with slope because it's curvy.
Like, can you plug in values for x and y?
Just any values?
Like the vertex values?
Well, let's do it more general first. We can plug in an ordered pair. I said yesterday that x and y are variables, and there's an infinite number of pairs of x, y, right? There is, for example, 2, 4. Would you agree that 2, 4 is a point on that parabola? That means when you put x into the equation, you have to get 4 for y. When you put x equals 2 into the equation, you have to get 4 for y. Let's do that, and then I'll talk about what you recommended, and we'll see that, unfortunately, that doesn't work, okay? So the answer is we're going to load in an ordered pair. We're going to put the x coordinate of a known point in for x, the y coordinate of that same point in for y, and we will get 4 is equal to a times 2 minus 3 quantity squared plus 1. And we are so close to having a grade 6 math question. Maybe not written in equation form, but because 2 minus 3 is negative 1, and when I square negative 1, I get 1. And 1 times a is a. It's not an exaggeration to say that a grade 6 student can find the value of a. You might have to not use an equation and say, we have 4 kittens, we had 1. Well, you wouldn't even have to do that. You could ask, what number, Peppermint Patty, do you add to 1 to get 4? And the answer would be 3. So a is equal to 3. At this level, we subtract 1 from both sides. We have a more formal approach, but a is 3. And now what we have is y equals a, which is 3, times x minus p, which I believe was 3 as well, quantity squared plus q, which is 1. And we're done. I do want to talk about what you just said, Georgia, though, about put in the coordinates for the vertex. Any point makes the equation true. The vertex will make this equation here true. But look what happens if we do that. We get 1 equals a times 3 minus 3 quantity squared plus 1. 3 minus 3 is 0. Congratulations, you have just proven that 1 equals 1. So by choosing the coordinates of the vertex, you eliminate the parameter in this case. So every point does make the equation true, but the vertex is a useless substitution, it turns out. Try one more. Well, take a minute and write the values of p and q by looking at where the vertex of this graph is. P is negative 2. Q is positive 1. Because the vertex is at negative 2 comma 1. Which means, everybody, and I'm going to write this up here. Whoops. I'm going to write this up here, although this should almost be burned into your brain by now. It would be on a formula sheet. I think it's on your formula sheet. It's on there. So listen to what I'm saying while I'm writing it. The function is y is equal to a times, and watch very carefully as you listen to my words, x minus negative 2, quantity squared, plus 1. Oh, what do we have? A missing parameter. How do you solve for a missing parameter? You load in an ordered pair for x and y, other than in this context, the vertex. I think this is a really good one to use, because one of the numbers is 0, which makes our work a little bit easier. So I can put in negative 2 for y, 0 for x, whoops, 0 for x, simplify and solve for a. I can subtract 1 from both sides and get negative 3 equals 4a. Just go slow here. 0 plus 2 is 2. 2 squared is 4. A times 4 is 4a. The negative 2 on the left, subtract the 1 on the right, gives negative 3. Now we know a is negative 3/4. And we're done. Well, we're not done. You have to write out the equation with that value of a. So the equation is y equals a times x minus negative 2 quantity squared plus 1. That's the function. And again, if we had longer classes, I guess we could sketch it and look at it and see that it matches. But I'm not worried about that. And in this example set number, or letter C, a parabola has a vertex at negative 2 comma 5 and passes through that point. I hope that you all recognize this is the exact same question we did in A and B, except that it's not giving you the information on a graph. The function will have to be y is equal to a, which we do not know, times x minus p, which we do. P is negative 2. So we'll have x plus 2 squared plus 5. How are we going to find a? Well, the fact that I'm doing the same question 3 times in a row tells you that it's a pretty important thing moving forward. You're going to see this a lot in the next course, and more in this course as well. You can load in an ordered pair, put 2 in for x, 7 in for y, and get 7 is equal to a times 2 plus 2 squared plus 5. Simplifying this, you get 7 equals 16a plus 5, because 2 plus 2 is 4, 4 squared is 16. Solving that is a junior high-ish kind of question. Subtract 2 from or 5 from both sides. Divide both sides by 16 to get 1/8. 2 over 16 is 1 over 8. So the function is 1 over 8 times x minus negative 2, which was p, quantity squared plus 5. I want to skip past 3. Okay, so let's turn the page to the next page, which I believe is going to be page 9. I'll probably just right at the end of class talk about number 3, but it's really leading up to something. In fact, the thing it's leading up to, I suppose we can do next class. So I don't think it's really crucial to what we're doing today in terms of your assignment. Okay. Suppose a parabolic archway, this is example 4 on page 9, has a width of 280 centimeters and a height of 240 centimeters at the highest point. I changed this from last semester. I just want to make sure that what I have up here matches what you have in your handout. Okay. Write a quadratic function in vertex form that models this shape if the bottom left of the archway is located at the origin. Because if I just take this shape and I put it here, and I say find the equation, it's going to be a different equation than if I put it here, or than if I put it here. So I'm giving you some guidance, and I'm saying we want to put this right there. What is the equation of this parabolic arch? Well, we need to know A, P, and Q. And in case you haven't clued in on this, this is going to be a missing parameter question. Because we can know the coordinates of the vertex. You just need to use a little bit of your sleuthing skills, your Sherlock Holmes skills. Knowing the width and the height is enough for you to find where the vertex is. If this is 280 centimeters in total, then that vertex will be at the halfway point because parabolas are symmetrical. It's the same shape on the left as the right. Well, half of 280 is 140. Because the bottom left of the archway is at the origin, in addition to that, the y-coordinate must be 240. Because this distance is 240 centimeters. So we know P and Q. P is 140. Q is 240. We're just about done. We've got to put those into the vertex form, then load in an ordered pair other than the vertex. Can't use the vertex to figure out the value of A. Our quadratic function will be, well, I'm going to use H for height. You could use Y, but this is really the height of a particular point on the archway. If that bothers you, use Y. Equals, we can still call this X, the distance from the left side. A, which we don't know, times X minus P, quantity squared, plus Q. How do we find the missing parameter? Just refer to it as that in your head, missing parameter. We load in an ordered pair. Man, what could be simpler than this? 0, 0 has to make this true. So when X is 0, H is 0. I'll test my mental math today. Is 140 squared, 19,600. So I need to subtract 240 and divide by 19,600. And because it's the last school day of the week of a long weekend for you guys, I don't see any reason why we need to stress our brains in reducing that down. Three 245ths. Negative. So what is the equation for H? Negative 3 245ths times X minus 140 quantity squared plus 240. And the last question we're going to do here, and I'm not even going to touch on 3 today. Are we okay with getting A there? The last question we're going to touch on is this. What is the height of the archway 50 centimeters from the outer edge? Well, all that's asking you to do is to go over here at 50 centimeters and find out how tall it is. It's asking you to put 50 in for x and find the height. Right? If you like, just, and I don't really care if you even write anything down here. Is this what it was? So did I get it right? If you like, think of it this way. H of x equals. The height as a function of x is that expression. So if I want to find the height when x is 50, I just put 50 in here. And this means, I'm just slowly getting you back into function notation. This means we're putting 50 in for x. And I'm just going to do it on my calculator. I'm old school math-wise, so I tend to do things in little chippy steps here. 50 minus 140 squared times negative 3 over 245 plus 240. The height is about 140 centimeters. That cannot be. Is that what you get as well? Oh, no, that's right. You know, when I saw that 140, I thought that's taller than the height because I was looking at the other thing, which was 140. It's not. I'm going to change this question because I think that's a horrible question, that we get an answer for this that happens to be the x coordinate of the vertex, which has nothing to do with the answer to this question, right? Anyway, the answer is approximately 141 centimeters. I should have played this out on my calculator before I typed it to make sure it wasn't, to make sure it was different, like maybe 80 centimeters or something. Anyway, that's it. I'm going to take a minute and go through these problems, and you get started on them and throw out a few that might have something to do with example 3. I want you to do 8. I want you to do 8. 6 and 7? No. I want you to do 8. And 9. 8 and 9. Missing parameter problems. We'll get back to the whole x and y intercept later, but do 8 and 9. That's what I want you to get done for Monday, or Tuesday rather.